All right, let's talk about one of the biggest mysteries in development. We're going to pull back the curtain and unlock the secrets that make a database either a lightning-fast race car or a painfully slow crawl. Let's get right into it.
You know the feeling, right? You've just built this amazing new feature. It works like a charm on your local machine, the code is beautiful, the logic is solid, and then you push it to production, and it all falls apart. Suddenly, a page that loaded in a blink is now just spinning, and the user complaints start flooding in.
This, my friends, is the classic production server nightmare. See, the feature itself hasn't changed, but the world around it has. Your tiny test database has grown into a monster with millions of records, and your perfect code is suddenly on its knees. So, what is actually going on here?
Okay, let me introduce you to the villain of our story, the full table scan. When your database gets a query and has no idea how to do it efficiently, it just gives up and resorts to brute force. Seriously, imagine trying to find a single word in a giant dictionary by starting on page 1 and reading every single page. That's a full table scan, and yeah, it's as slow as it sounds.
And here you can see that difference in black and white. On the left, you've got that brute force read everything full table scan. But on the right, that's the smart way, an index seek. Instead of reading the whole book, the database just looks at a special table of contents and jumps right to the data it needs. This is the hero of our story.
So let's talk about this hero, this magical table of contents we keep mentioning. Well, it's called an index, and it is the absolute key to turning a performance nightmare into a dream come true.
So what is an index really? It's just a separate, super organized data structure. Now, you'll hear the term B-tree thrown around. Don't worry about the jargon. Just think of it as a really smart, self-organizing map. Its entire purpose in life is to give the database a shortcut so it can find the exact location of your data without having to dig through millions of rows it doesn't care about.
Now, to really see the impact, we look at a metric called logical reads. It's basically how many pages of data the database has to go and look at to get an answer. And without an index, for our query, it has to perform a mind-boggling 50,000 logical reads. That is a ton of work.
And now, for the big reveal. We add one simple, straightforward index, and look what happens to that number. From 50,000 down to just 50. I mean, come on, that's not a small improvement. That's 1,000 times more efficient. This right here is exactly why indexing is completely non-negotiable for performance.
Okay, so a simple index fixes a simple problem. Easy enough. But what happens when the real world gets messy? Real applications ask complicated questions, right? For that, we're going to need a much more powerful tool. We need the composite index.
Picture this. Your boss walks over and says, "Hey, I need you to find all the orders for this one customer that were placed during this specific month." It sounds like a totally normal request, but look closely. There are two conditions here, the customer and the date, and a simple single-column index just isn't going to cut it.
And here's the trap that so many people fall into. They think, oh, I'll just create two separate indexes, one for the customer, one for the date. But here's the problem. The database is probably only going to use one of them, so it'll use the customer index to find all 10,000 orders from that person, and then it has to manually scan through all of them to find the ones for November. We're right back to scanning, and the query is still way too slow.
This is where we unleash the ultimate weapon, the composite index. Instead of two separate, kind of helpful indexes, we create one single, super powerful index that includes both columns. This lets the database use its table of contents to zoom in on the customer and the date all in one shot. It's incredibly efficient.
And you don't have to take my word for it. Just look at the database's own plan. The query cost, which is its own estimate of how hard it has to work, plummets from a hefty 85% with single indexes all the way down to a tiny 15% with a composite index. That right there is a game changer.
But wait, it's not quite that simple. You can't just throw a bunch of columns into a composite index and call it a day. To really, truly master this stuff, you have to understand the biggest secret of all. The order of the columns matters a lot.
The key concept you need to get is called selectivity. All it means is how unique is the data in a column. For example, a customer ID column has super high selectivity because almost every single value is different. But a status column that only has a few options like new, done, canceled, that has very low selectivity.
And that brings us to the golden rule, the one thing you have to remember. In a composite index, you always put the column with the highest selectivity first. Why? Because you want to get rid of the biggest chunk of irrelevant data right away. By starting with the most unique filter, you make the problem smaller, faster.
Just look at the difference this makes. If you do it the wrong way and put the low selectivity status column first, the database has to find millions of done orders and then search through that giant pile for your one customer. The performance is poor, but if you flip them, put the high selectivity customer ID first, and bam! The database instantly narrows the search down to just a handful of rows. The performance is excellent.
Okay, so you've done it. You've built the perfect composite index. The columns are in the perfect order. You are a true indexing master. You run your query, and the database does a full table scan anyway. What is going on?
Honestly, this is the moment that makes developers want to pull their hair out. You did everything by the book, and it feels like the database is just ignoring you, being stubborn. You start to think maybe it's broken, but I promise you, there is a very, very smart reason for what it's doing.
Here's the thing. It's not broken. It's actually being incredibly smart. You need to meet the brain of the database, the cost-based optimizer, or CBO. Its entire job, all day long, is to calculate the absolute cheapest, most efficient way to get you your data, even if that means ignoring your perfectly crafted index.
Here's how it thinks. An index is amazing for finding a needle in a haystack, a few specific rows out of millions. But what if your query is asking for, say, 40% of the entire table? Think about it this way. If you need to copy a whole chapter from a book, what's faster? Looking up every single word in the index at the back of the book, one by one by one, or just flipping to the chapter and reading it straight through? The straight-through read is way faster, and that's a full scan.
So let's wrap this all up. What are the key takeaways? First, indexes are your table of contents, and their whole job is to crush those logical reads. Second, when your queries get complicated, you need to reach for a powerful composite index. Third, remember the golden rule. High selectivity columns always go first. And finally, learn to trust the optimizer. Sometimes that full scan you hate is actually the smartest move.
See, your database isn't just a dumb box for storing data. It's this incredibly sophisticated system that's always trying to find the most efficient way to do its job. So the real question is, now that you know all this, are you giving it the right tools to help it succeed? I really hope this helps you do just that. Thanks for tuning in.